and welcome back again for AWS and DevOps series. Today we are going to have another session on EC2. It's a deep dive session too. Today we are going to conclude most of the topics on EC2. The remaining topics, earlier we have seen what is an EC2 instance, security groups, Amazon Mesh and images related to that. But today we are going to understand some basic important topics on this, especially one is load balancing and other one is auto scaling group. So that there are three types of load balancers in AWS. One is application load balancer, and network load balancer, and a gateway load balancers. Okay, there are also some other load balancer called as classic. We are not going to discuss in much detail on this because this is an old version of the load balancer. We are not using this much. Will be offloaded very soon from Amazon. There is also called a target groups, and under auto scaling groups there are some concepts of launch templates, some scaling policies, and CloudWatch alarms. So this CloudWatch alarms we might not see right now, but we will be seeing when we are dealing with especially the CloudWatch service. But we'll be basically understanding exactly what this load balancing is and what this auto scaling is with some simple example. Okay, so let me take this EC2 auto scaling group or load balancing. Okay, so before getting into this topic, let's understand a simple scenario, a real-time scenario. Like you are a shopkeeper. Okay, so you own a shop which is nothing but a merchandise store. Okay, so under your merchandise store you have three salespersons who will sell your goods. This is a physical shop who will what do you say, explain about your goods which are there in your merchandise store. It can be clothes, it can be electronic appliances, it can be anything. It's a store. Okay, so where you have different kinds of appliances or different kinds of clothes, or it can be garments, anything. So there are three salespersons in your shop who will explain the customers and sell your products to them. Okay, so these are your products. Like let us say for example these are your set of products. So they are going to sell the products to your end customers. Okay, so let us say for example there are uh, three customers who are coming to your what do you say, shop. So let us say there are three customers coming to your shop at the same time. So what you do is generally to accommodate all these persons, all these customers at once, you divide the customers. Hey, hi, you just speak with customer one and send it to the salesperson one. Let us say him as a salesperson. We just send to the salesperson one. You'll just send the second to salesperson two and third to salesperson three. In the similar fashion, based on the people who are coming, customers who are coming to a shop, you will just divide the customers equally among the salespersons who are available, so that your customers will get your explanation about the products, and you can sell your products at a higher rate. Because if there are five customers standing at this same person and these two persons are idle, you might not have that much of sales, because he can only sell a product to a single person at a time. So other four persons will not be having any kind of information about that, and they might be at a place like they might not purchase any goods at your store. So this is a concept called as he is balancing the incoming traffic, or this person or you are balancing the incoming traffic among the three salesperson sitting behind. Okay, and let us say you are having a staff room where there are extra salesperson sitting, so that let us say for example it's a Sunday, your customer stock is high. Like there for example there are like 40 to 50 customers came at the same point. So then what the shopkeeper do is he just calls to the extra staff and asks them to come and sit on the counter so that they can serve more customers and sell their products. Okay, so you just call and then more will be coming onto the floor and they are going to serve the customers. Okay, so this process is generally called as the auto scaling groups. Okay, so the same thing, whatever we have understood right now, you are nothing but you're serving your what do you say, your store or anything. You're balancing your customer traffic, and you're ensuring that your customers are getting the right products at the right place with low latency, or nothing but with less amount of time they are purchasing their goods. Okay, so coming in the similar fashion, let's understand in a software perspective. Okay, a software perspective. Let us say you are having an application, a software or an online application. Okay, so your online application is there on server 1. Okay, so there is a user 1 who is trying to access this application, so he is getting served. Let us say, for example, there are 100 such users, or let us say, for example, 1000 such users try to access the application at the same point. They might get some kind of latency, or they might not be able to see the application for some amount of time, because this server might not accommodate 1000 requests at the same time. So at that time, what you do is you just build another server called server 2. Now the question here is, I cannot come and say that, or I cannot write any application that, okay, first 50 requests go here, next 50 requests go here, something like that. Okay, so you cannot manually change, or you cannot do it like, okay, based on the customer, like first 1000 customers just go here, next 1000 customers go here. No, you cannot do that. So to do that, we have a service called Elastic Load Balancer. Okay, so this Elastic Load Balancer, what it does is, like, let us say, for example, there are 1000 customers coming to your application, so this is your application altogether. Okay, so we call this as a target group. We call this as Elastic Load Balancer. Let us say, for example, 1000 customers are coming to your application. So this AWS Elastic Load Balancer is smart enough to divide the traffic. So 1000, it just divides the traffic like 340, 340, and just 340. Or let us say there are only 2 servers, so it just divides 500 and 500. You need not to explicitly handle any kind of the traffic loading or latencies related stuff on your servers. Elastic Load Balancer takes care of that. Based on the incoming traffic that is coming to the load balancer, it divides them equally among the servers, and it serves the application to the end users with very low latency. Okay, so this is what generally Elastic Load Balancing speaks about. Elastic Load Balancing is nothing but it balances your traffic which is incoming to your application. It sits in front of your servers and balance the traffic and sends equal amount of traffic, so that less load will be there will be a less load on the servers, so that you can have a more and more high availability for your application, so that the customers can experience very rich and fastness on your application to purchase their orders or something. Okay, so now let us say, for example, there are like 1 million customers on a festival or something. Your 2 servers cannot accommodate that. So at that point of time, like how we got some extra persons onto the floor to sell your goods, we also need an extra server, correct? So we also need an extra server. So the capability of increasing the extra servers, or the capability of increasing the extra capacity based on the load, we call that as the scaling capacity, and we call that as auto scaling capacity or auto scaling group. Okay, so the ability to scale itself, or the ability to scale in or scale out in AWS for an EC2 instance, we call it as an auto scaling group. Okay, so we call that as an auto scaling group because AWS has that capability based on the load that is present on the servers. Let us say, for example, if there is 95% of CPU, the average CPU on the servers, I'll say, okay, if there is 95% of average CPU, spin up a new server. If there is only 50% of average CPU, keep only 2 servers. If it is on 95, put another server, so that if there are 1 million requests, it will be divided on these 3 servers rather than only on the 2 servers. Because this is what happens when, let us say, for example, in general, if we think on Amazon sale, or Amazon Independence Day sale, or Flipkart Big Billion Day sales, at that particular point of time, the infrastructure or the capacity for these applications increases automatically based on the load that it gets. So it increases dynamically based on the load. So here we are not procuring the servers in hand or before in hand based on the what do you say, the traffic demand. We are dynamically increasing our capacity based on the demand. So this dynamically ability to increase your capacity or withstand to the traffic that are coming to your application is called as an auto scaling or auto scaling group in EC2. Okay, so these are the two major concepts: elastic load balancer and auto scaling group. These two always goes together whenever you are learning on AWS. Okay, so let's get into this key concept what we have learned. So that's what we are speaking on this load balancing, or just a second. Okay, so this load balancing and auto scaling group. So all this load balancer, there are three types of load balancers: application load balancer, network load balancer, and gateway. We will see all this in console, like what is the basic difference between them. But most of the AWS DevOps engineers or most of the developers who are working out in the market, so our most area of work lies in application load balancers. In network load balancers, just generally operates on TCP and UDP layers, where high with a low latency and a high bandwidth and high data transfer rates, we generally choose this network load balancers. And gateway is for it's itself says a gateway, so it for virtual appliances or some kind of VPC connections, or making a connectivity between two VPs, or setting up the gateway, so that this also provides some high bandwidth and providing that balance in between the huge traffics. But most of our HTTP or HTTPS requests will be routing through an application load balancer. We will also see an implementation of an application, but not on gateway or a network. You also see this classic or old type of load balancer. Currently, this we are not using. We are not going to touch base any of these things because I haven't seen any recent questions on this, even on the certifications, nor in any kind of implementations. So you can just skip this classic. I just introduced into the slide so that you'll just understand. In the console you see this classic. So this is also a type of load balancer, but it has very less features compared to application. So all the features that are present in classic will be available in application. So this is the latest load balancer. So you generally, whenever you come across an interview as a DevOps engineer or AWS cloud engineer, the one basic question you get is what are the different types of load balancers and what requests do they support. So that's basic requests like HTTP or HTTPS requests are supported by an application, and TCP and UDP requests, those protocols are supported by network, and virtual appliances requests are supported by gateway. And classic is an old generation load balancer where HTTP and HTTPS routes are supported, but at a limitation. So those limitations we are not going to cover on this video or this series because we are not concentrating on this. And this auto scaling groups, again, this launch templates are nothing but you are providing the information. As we seen yesterday, this launch templates gives you the information about how the EC2 instance should be, like operating system, compute type, and like what all the different security groups. It can be other options. So whenever a new instance is launched, like for example, whenever we discussed here, we were discussing like there are multiple servers that are getting launched over here. So what is the configuration of this particular servers will be available or will be present on that launch template. Okay, so we'll also see the scaling policies. We'll just touch base on this, but we'll be deep diving on this in a use cases series. So this is the AWS DevOps training series, but there is another series for use cases where we'll be discussing the detailed implementation. There we are not going to discuss anything on theory, but those series of videos will be direct implementation of some use cases and an architecture. So there we can see multiple things of scaling policies. But here in this demonstration today, we will see a target scaling policy, which is nothing but it will ensure the number of servers are always remain at a desired state. So it always it ensures like for example, there should be 2 servers at any given point of time based on the load, so that 2 servers will be maintained. So this speaks about the scaling policies. When you want to scale your server, when you want to scale in, or when you want to scale out, those informations will be present on this. This CloudWatch allowance is nothing but whenever you launch a server or whenever you terminate the server, all these informations will be present on the CloudWatch allowance. It's nothing but notifying you based on that. So we will see all this in action. because let us say we are going to implement this typical EC2 load balancer architecture demo right now. So it says like the similar stuff. There will be users who will be interacting to the application load balancer. So based on that load, we are going to have multiple EC2 servers. Okay, so we are going to deploy, or we are going to set up this architecture where we will be querying, or we will be browsing through this application load balancer URL. We are going to hit this URL using an HTTP request, and we will be setting up an auto scaling group behind this application load balancer, and we will launch a couple of servers and see how the requests are getting routed. And we will also see what if some server goes down, will the AWS launch another server automatically or not. So we are going to implement this simple architecture. It's a very simple architecture of EC2 backed with a load balancer or something like that. Okay, so this is again this reference or this example is directly taken from the Amazon. So I'm just implementing the example architecture provided by Amazon. So you can just have the detailed explanation of this architecture even in this tutorial. I'm just trying to implement this because this is the latest example given by Amazon on their docs. Okay, so let's get into the console, and we are going to see much in detail. Okay, to implement this architecture, EC2 backed load balancer architecture, so these are some detailed steps I have listed down so that it will be easy when we are implementing, or when you want to implement of your own, rather than just going back to the video again and again. You can just note down these steps and you will understand how you are going to implement this. So let's go step by step. So first we need to ensure, like for example, whenever you are launching instances in an auto scaling group, at least you need to have two subnets in which you can launch your instances. So if you are not sure about what is a subnet and what is an availability zone, you can just revisit my first video on AWS architecture, where we have detailed explanation on availability zones and all. But again, we are going to discuss in detail what is a subnet and what is a VPC and all in a separate section when we cover VPC. But for now, let's log into AWS console, and let's launch a subnet, a public subnet. To create a public subnet, you need to navigate to a service called VPC. Start typing VPC and select this. You will land into a page where you will be having a default VPC which has been created as a free tier account as soon as you create it. Okay, so I'm going into the subnets for this. So let me click on my subnet. Initially, previously, when you used to have the free tier account, you used to have two subnets. But the latest free tier accounts, if you create, you will be having only one subnet. So I have renamed this subnet to my subnet 01. But when you open your free tier account, this will not be named like this. Okay, so let's create a subnet. Select the default VPC which is present, and this is a default CIDR block. We are going to discuss the CIDR block and what is this CIDR ranges and all in detail when we discuss about VPC. But for now, just follow this procedure for creating a public subnet, because we are much interested to understand the load balancing and auto scaling architecture. I'm going to give this as my subnet 02, and availability zone as the current current subnet is present in US East 1A. So I'll be selecting US East 1B for now, and I'll be providing a CIDR block based on this range. So just take this if your CIDR block is in this range, or just check your CIDR block of subnet of your whatever the existing subnet. So based on that, I have provided this CIDR range. You can use based on your choice. So just create the subnet. This should be creating a subnet in a couple of minutes. So I'll just refresh this. My subnet should be ready. So my subnet is ready. So if you can just click here, I am having two subnets. So now once this subnet is created, you need to jump to the next step based on what we are discussing is set up launch template. To set up launch template, you need to get into EC2. Start typing EC2. Click on EC2. You will land there. So once you are on EC2, this launch template, you can create the launch template like you can just name it as LT1 launch template 1, and let's mention as version V1. Click on this so that you will get some guidance when you are creating this autoscaling group, the template for autoscaling group. I'll select the operating system as Amazon Linux. So let's wait for this gets loaded. It will be loading whatever the operating system and all, architecture and Amazon Linux description. So now I'll be selecting the instance type as T2 micro because that's free tier eligible. I'll be selecting the key pair which I have already created. And in the network settings, please do not select a subnet because your EC2 instances will be launched across the subnets. So AWS will be launching the instances based on the availability, because if your servers are already present in subnet 1, it tries to launch us in subnet 2. So please don't select this subnet, and you can select an existing group or create an existing create a security group. Let's create a security group like my ASG security group. Description can be a web server SG. It's a VPC, you can just keep it as default. Let me add an inbound security group rule, like I want to allow a HTTP traffic across the internet, so I'm just keeping that as is. So you can ignore the warning. I can have a default of 8 gigs of RAM, I mean like 8 gigs of volume, that should be fine. And if you click on the advanced details, we have seen all these details in detail when we have in a deep dive session 1. But for me, I'm much more interested on having this metadata to be enabled, because I'll show that, and I want to have this V1 and V2 token optional. And I want some user data for installing a web server as soon as the instance is launched. So I have that code ready on my GitHub, so I'll be just taking that. So let me copy that, I'll paste it here. So if you see why I have enabled this metadata, because if you curl this particular URL on any of the instance ID on any of the EC2 instance, you can get the metadata associated with that particular instance. So this curl on this HTTP URL will be utilized for accessing the metadata of this instance. You will be having a lot of other options on this metadata. You can just get into internet and see on the AWS docs what are the other metadata options available. I'm just grabbing this instance ID and just pasting that instance ID as a header on this index.html, so that whenever I browse via the load balancer URL, I should see the instance ID of this server. And because this instance ID will be different for different servers, so when I hit the load balancer URL and if I try to hit it multiple times, I want to see a different server hitting, I want to see the load balancer hitting multiple servers so that I can see the change in instance ID. It says that this load balancer is routing my traffic to a different server. So that's why I've provided this. Now you can create a launch template. So this launch template will be created. So you can see it's getting created. You can just click on the details. That's initializing request, and creates launch template has been successful. Now quickly we are going to create a target group for this. So as we discussed earlier, target group is a place where our instances will be lying. The autoscaling groups will be attached to serve the application. So let's quickly create this target group. So I'm just selecting this as instances. You'll have another options for selecting IP address, Lambda function, and application load balancer. But our applications are on autoscaling EC2 instances. So I'm selecting the instances as my default option. So let me select my target group as TG1. Protocol is HTTP and port is port 80. So let's select the default VPC and a protocol version. If you see this health check protocol, so health check is nothing but target groups always perform a health check on your instances to see whether your application is running fine or not. You can place any path on this. I'll be keeping it as default because my application will be there on the root path. On the Apache server, it will verify whether the application is running fine or not. If it is not running fine, it will mark as unhealthy. If it is working fine, it will mark as healthy. The unhealthy servers will not be served for the application behind this target group and behind the load balancer. You can have also advanced health checks, like what is the health check port. You can override the traffic port, and you can also have the healthy threshold. The healthy threshold says that after how many consecutive health check passed. Okay, as we discussed earlier, health check is nothing but the if the target group hits your instance, if it is able to serve the application, it says as a health check. So if the health check threshold is nothing but after how many consecutive health checks, the successful health checks, it will mark your instance as healthy. And if there are two number of unhealthy thresholds, then your instance will be marked as unhealthy. If your instance is not able to serve the application for two consecutive health checks, so you will be marked as a failure. So timeout is nothing but it will wait for your response until 5 seconds. For example, if target group is trying to do a health check, it will wait for 5 seconds for the response, for a 200 response or a ping back. If it is not getting that in the 5 seconds, it will mark as a timeout or a failed health check. So coming back to the interval, so this interval is nothing but a duration between two health checks. It will maintain as like 30 seconds. It will take from one interval to another interval. So the out of 150 seconds, it will mark whether it's healthy or unhealthy. So this is a success codes that will be used for setting up your target groups. You can mention any codes other than this. So this is a default value, but you can have any code based on your application. Okay, so let's go to the bottom and just click next. And I'm not going to add any instances right now because my instances will be added via the auto scaling group. So click on create target group. So my target group has been created. So now the next step is to create a load balancer. So let me get into the load balancer console and click on create load balancer. If you see in the load balancer types, as we discussed earlier, there are three different load balancers: application, network, and gateway. So this application load balancer majorly deals with the HTTP or HTTPS load balancers. I mean, like type of requests where web servers will be mostly served. And this network type of load balancer, majorly TCP, UDP protocols will be served from this network load balancers, and kind of virtual applications or VPC based routings. All this comes into a gateway load balancer. But most of our trainings will be dealing with application load balancer because all of our web servers, DevOps engineers majorly work on this application. So we might have requests on network load balancer, but majorly our training is intended for dealing with the application load balancer. So let us hit create. So this is the older one, the classic load balancer, if you see on the bottom. So this was the older generation load balancer which AWS was having. So currently we are not having this load balancer for any kind of purposes. So we have already migrated everything to application load balancer, networks, or a gateway. So this will be obsolete in very soon. So this was the older one. So it just present here, but I always encourage to, for any kind of HTTP or a web server based applications, you can go ahead for an application load balancer. Just click create. You can also see how this load balancer works. So the two major terminologies in application load balancer or the load balancer and the rule, load balancer rule and the target. So whenever if you see a load balancer, as we seen earlier in the diagram, this is the load balancer and these are the traffics that are getting served behind the load balancer. Okay, so a load balancer always checks for the listeners. A listener is nothing but who is listening for the request on the load balancer. So a listener can be a target group here. So this target group will be listened on port 80. So we call it as a rule. So it's nothing but we will be writing the rule on Elastic Load Balancer stating that if traffic comes on port 80 on load balancer, please route it to a target group 1. This is what we are going to write on application load balancer as a listener rule. So if you can just scroll down, so let me name my load balancer as LB1 and it's an internet facing and IPv4 address. So I have my VPC as default and just select the default subnets. Okay, and a default security group. Please ensure a HTTP rule has been enabled in the inbound of the security group default for load balancer, else you will be having a timeout on your load balancer. So in listeners and routing, so I'll be selecting my target group which I have created earlier. So whatever the requests that are coming on HTTP via HTTP protocol to port 80, please route this to target group 1. So currently I don't have instances. Next I'll be launching the auto scaling group. So that auto scaling group will be launching the instances into this target group. Okay, so this is the rule we maintain. You can have n number of rules on this, like you can add a listener, a different listener, different protocols, different port, you can just forward to this. So like that you can have multiple, but for now we are just interested on a port 80 and forwarding it to a target group 1. So I'm not interested on this add-on services for now. So these are the tags. So this is the summary. So let's get and create the load balancer. So your load balancer has been successfully created. You can just click on this. You can see the load balancer 1. It's in the state of provisioning. So if you just refresh, it should be available very soon. Okay, so let's see the state of it. It's still provisioning. It is active, so it took like 2 to 3 minutes for me for coming this to a state of active. So the next step is to create the auto scaling group. So let's get into the auto scaling group and let's see what are the different options available there. So we already remember we have created a launch template. You can directly get into the launch template and select this and create an auto scaling group from this, but also you can also create it from here. Both are same. You can also have a detailed explanation about like what is Amazon EC2 auto scaling, like how does it works, what's the minimum size, scale out needed, maximum size, and a desired capacity. So all this information, it will be present. So this is what we have already seen till now. So auto scaling group is nothing but the ability of scaling your instance based on the input load. So let's get into creating an auto scaling group. So let's ASG1, let's name it as ASG1, and I'll be selecting the launch template which I've created earlier. So the version is a default version. So all the values are loaded, my ID and my key pair name and a security group IDs, everything has been loaded. So let's just click on next. Let me select my default VPC and select the couple of subnets so that your application will be loaded in 2 different servers. If I select it as desired capacity of 2, so that just select 2 subnets which you have present right now. So instance requirements, these are default. You can just override the launch templates if you want to edit it, but I'm just keeping it as free tier. So I'll just click next. So in this, you should be adding the load balancer, to which load balancer your auto scaling group should be attached to. So I've already created my load balancer, so I'll be attaching to an existing load balancer, and you can choose from your load balancer target groups. Okay, so I'll be selecting my target 1 group as my instance auto scaling group target group, so that it will be added to it. So based on the load balancer target group, it will be attached to it. Okay, so we are not much interested in the VPC lattice integration options. So the health checks again, even on the load balancer, it will check for the health checks on EC2. Like for example, it will check whether the instance is available to handle requests or not. Then only EC2 will suggest, or EC2 will send traffic to the target group, or nothing but the instance. Okay, so this health check grace period is nothing but after it will wait for certain amount of time until it starts checking for a health check, because your application currently our user data is only for launching a simple EC2 instance, but at some times you will be having like it will be launching a huge application. At that particular times you need to have that amount of grace period for which you need to wait until load balancer checks for its health check or something like that. Okay, so just scroll down, and these are additional settings, so you can just skip it. Just click next. So desired capacity is nothing but at any given point of time, what is your size of your EC2 instance should be. So let me keep it as 2. And what is the minimum capacity? So I should not scale in my application, scale out my application more than less than 1 server. So my minimum should be 1 server and my maximum should be 3 servers. So if my traffic is increased a lot, so then it should be a maximum of 3, and if my traffic is increased, so I can reduce by 1, but at any given point of time I should have a desired capacity of 2. And this scaling policies are optional for now, but I'll be setting this as a target tracking scaling policy, there are multiple scaling policies that are available on the auto scaling group. You can just click on this and get into the documentation and learn what are the different EC2 scaling policies. Like there will be manual scaling, or in the dynamic scaling there are multiple target tracking scaling, step scaling, simple scaling. So these are much important if you are working, if you are going ahead for certification exams or anything. So this dynamic scaling policies are a bit important. But for now, for this demo, just ensure this target tracking scaling policy is nothing but it will check for your average CPU utilization on your server. If it is more than, like for example, more than 70%, it will launch a new server. Okay, so instance warm up is nothing but it will wait for this amount of time until the instance has been launched and it comes into the healthy state, or it comes into the available state. Okay, so get into the instance scaling. You can just skip for now this demo. Just click next. I don't want to add any notifications. Click next and click next. You can just review all the options which you have there and click the auto scaling group now. Okay, so your auto scaling group will get started as soon as you create the auto scaling group. You can just refresh, you will see the instances are getting created. So if you click on this activity, it says that what activity this auto scaling group is doing. So let me scroll down a little bit so that you will see a detailed activity of this auto scaling group. Okay, if you see, it's launching a new EC2 instance because it want to maintain the desired capacity to 2. So there are 2 instances that are getting launched. You can just refresh it. It has been successful. So your 2 instances has been launched. You can see even on the EC2 pane, logging into the EC2 pane, and you can see the 2 instances are running state. Okay, you can see there are 2 instances that will be launched via an auto scaling group and they are in running state. So these are the 2 instances that came from the auto scaling group and they are in running state now. So now let me get into the target group and check if these are in healthy state or not. Okay, if you see these are in healthy state, you can see 2 servers has been added to this target group and they are healthy. And now let me check whether this load balancer has been attached to this target group, has been attached to this load balancer or not. Okay, so let me see. Yes, on port 80 a target group 1 has been attached, and in the target group 1 I can able to see that there are 2 servers, 2 healthy servers where my application is deployed and where my application can be served. So now you have seen the architecture of this. See, like you have launched the application load balancer, you have launched the auto scaling group, and in the auto scaling group you have launched, I have launched only two servers just for as a free trial, so you can launch 3 or 4 as many as you want. Now our task is to hit this load balancer URL and see whether we are able to access these servers or not. Okay, so now let me get into the load balancer. So where is my load balancer? Yeah, load balancer 1. Click on this DNS name. Let me go to the URL, just paste it, port 80. Just see whether I am able to get my application or not. Okay, so you also needs to see, if you see I am able to get the instance ID of what is this, one of the instance. I'm just seeing what is that particular instance. If you see, I'm getting an instance. Check. I'm on PC, the running states instances. Okay, so which these are launched just launch time is just now. Okay, so if I can see the instance ID, it's D877. So this is the instance ID. If I refresh it, if I refresh for multiple times, I can see another instance ID which is 64FA, which is the second instance. It says that application load balancer is dividing or it's managing the traffic which is coming to it. Okay, it's managing the traffic which is coming to it. So that's why if you can just refresh again, you can see the traffic is loading, or traffic is what do you say, it's diverting the traffic, it's managing the traffic based on the load. If I'm hitting multiple times, I'm not getting served from the same server, it's getting served from the different server, because I tried to print in the HTML page the instance ID, so this says these are different servers. Okay, so now that's what even in this table we have seen till this creation of autoscaling group. So this, I'm just curious, I've just added this tab because if you are a free tier account, your default security group of load balancer, like for example of your load balancers, because I've seen these cases, students are facing this. So if you click on this load balancer and just go to the security group of this, a default security group, so you might not be adding this what do you say, the inbound rule for port HTTP, the HTTP inbound port, you might not be added, so this is not added by default. Okay, so you need to explicitly add it, so then only you will not get a timeout on this, else you will do the same architecture but you will be getting a timeout. So this could be one of the reason for that, so that's why I've added this. And delete any one of the EC2 instance and verify if it is scaling the instance automatically or not. Okay, so let me delete any one of the EC2 instance. So let me get into the instances, and okay, so let me delete this or terminate this EC2 instance. Click on this instance state, terminate. So I'm completely terminating this instance. So according to me, my traffic will be served only by single instance for now. Okay, if you see, I'm just getting a bad gateway because this is getting served by a different server which is terminated. Now if you see multiple times, I'm getting only the request from a single server which is 4FA, which is live. Okay, even if you see on the target group, you can see that instance will be in a draining state. It says that it's offloading from the target group because it is unable to serve the application. Okay, just click on this, scroll down and just go to the targets. If you see, there is only one server, there is no other server because it got terminated. Now you can also see in the auto scaling group that if you click on the auto scaling group, coming to the auto scaling group which you have launched, you can see the auto scaling groups you have launched here. Click on this auto scaling group, and you can also see whatever the activities that it is auto scaling is doing. So just if you see, there is 2 instances it has launched. After that, an instance was taken out of service in response to an EC2 health check indicating it has been terminated or stopped. Autoscaling group has detected that an instance ending with this D877 was terminated. So that's why it has removing this, or its connection draining in progress. So also to maintain the desired capacity, it's launching a new server. If you can just refresh it, it launched a new server. You can just get into the instances again in the running state. You can see there is one more instance that got the 2 instances or running state. You can also check on the target groups, get into the target group. Let me close all the sub tabs which we have opened recently so that it will be more clear for you. So I'm opening this target groups in this. So you can click on this target groups. You can see these 2 instances are registered again and they are healthy. In a similar fashion, you can also try deleting completely 2 servers, or you can add a few more servers by increasing the load. But increasing load, we cannot do it in a practice or a kind of testing. So I just try to terminate the server so that you can see whether the new server has been launched or not. You can also see on the auto scaling group the activity of it, what happened in detail. Okay, so it says like some alarm tracking, some policy change as desired, so it's shrinking the capacity, something like that. So it's the desired capacity has been moved to 1 based on the, I've given the CPU utilization if it is less than 50 it's going to the minimum capacity to 1. Okay, because in the automatic scaling I have given the target tracking policy as required to maintain average CPU utilization at 70. Add or more remove capacity units as required. Okay, so for that it's showing as in the activity stating that a monitor alarm target tracking AS1 in state alarm target tracking policy changed the desired capacity from 2 to 1 because it has taken the consideration of the CPU utilization, which is very far less than 70. Okay, we are not even doing anything on the EC2 server, so it has recognized that on an alarm on this automatic scaling, because we have implemented this automatic scaling stating that hey, your auto scaling group doesn't require 2 instances because you are not using much of it. So based on that, it's automatically dynamically scaled it. Okay, it's dynamically scaled that from desired from 2 to 1. Okay, it says that. So that automatic alarm also ensures like your scaling has been maintained, or you are not spending too much costs on this. Okay, you can just click on this load balancer. You can also see there is one server, couple of servers that are getting launched, or that are getting served. You can see the change of that load balancer, or this instance ID name if a new instance has been launched. You can also try like deleting out all the servers on this auto scaling group. You can see like for example, get into the instances pane and try deleting all the 2 servers which are in running state. If there is only one, you can just delete both of that and check whether it's running fine or not. But again, so the same thing, if you want to get into the application, get into the load balancer, get the load balancer DNS like this, and hit it on the internet by providing some IP like this. So you can hit on that. You can just try pushing this. So this will give you different load balancers. So now we are getting only single load balancer because my auto scaling capacity has been reduced from desired state 2 to 1. Okay, my desired state has been become from 2 to 1 because I'm not using any capacity of my EC2 instance. So this automatic scaling has been reduced to the desired capacity of 1. Even in the target group, if you see, I hope a draining should be happened. Okay, so a training should be happened on this. So this activity will be doing that. On this ASG1 under activity, you can see that a terminating EC2 instance connection draining in progress. So that's why you are not seeing the other EC2 instance which is coming in. Okay, so this is how it works generally on the auto scaling groups and all. You can just try multiple use cases on auto scaling groups. You can come back with some more questions. You can just hit on this GitHub, get into the discussions forum on AWS DevOps learning. You can start up any discussion and you can just point out any questions on this. I'll be here to answering that. Thank you. Have a great day. Bye bye.